NFPA 70E, the standard for electrical safety in the workplace, addresses the use of rubber mats and other safety precautions in relation to voltage levels. Specifically, Section 110.16c outlines the requirements. The answer to the question is 600 volts alternating current, or 900 volts direct current. At or above these voltage levels, the standard mandates the use of a rubber mat or equivalent insulation to protect workers from electrical shock. The reasoning behind this requirement is based on the increased risk of electrical hazards at higher voltages. At 600 volts alternating current and 900 volts direct current, the potential for arc flash, shock, and other electrical injuries becomes significantly greater. Therefore, additional safety measures are necessary to mitigate these risks. Rubber mats, specifically those designed for electrical safety, provide an insulating barrier between the worker and ground. This barrier helps to prevent electrical current from flowing through the worker's body in the event of contact with a live conductor or energized equipment. The effectiveness of a rubber mat depends on several factors, including its dielectric strength, thickness, and condition. Dielectric strength refers to the mat's ability to withstand high voltage without breaking down and allowing current to pass through. Thickness is also important because a thicker mat generally provides greater insulation. The condition of the mat is critical, as any cuts, tears, or punctures can compromise its insulating properties. Regularly inspect rubber mats for any signs of damage and replace them immediately if any defects are found. It is essential to ensure that the rubber mat being used meets the appropriate safety standards for the voltage levels involved. These standards typically specify the required dielectric strength, thickness, and other performance characteristics. Look for mats that are labeled as meeting or exceeding recognized industry standards. In addition to rubber mats, other types of insulating materials may also be used to provide protection from electrical shock. These include insulating blankets, gloves, sleeves, and tools. The selection of appropriate protective equipment depends on the specific task being performed and the voltage levels involved. Always follow the manufacturer's instructions for the proper use and maintenance of all safety equipment. Remember that rubber mats and other safety equipment are just one component of a comprehensive electrical safety program. A comprehensive program should also include proper training, hazard assessments, lockout-tagout procedures, and other safety measures. Training is crucial for ensuring that workers understand the hazards associated with electricity and how to protect themselves. Hazard assessment should be conducted to identify potential electrical hazards in a workplace. Lockout-tagout procedures are used to de-energize equipment before performing maintenance or repairs. By implementing a comprehensive electrical safety program, organizations can significantly reduce the risk of electrical injuries and fatalities. When working with electricity, it is always better to err on the side of caution. If there is any doubt about the safety of a particular situation, stop work and consult with a qualified electrical professional. Electricity is a powerful force, and it must be treated with respect. Always follow all safety procedures and use appropriate safety equipment to protect yourself from electrical hazards. Therefore, the minimum voltage level that requires a rubber mat to be placed at the work area, according to NFPA 70 Section 110.16c, is 600 volts alternating current or 900 volts direct current. Understanding and adhering to this standard is essential for maintaining a safe working environment and preventing electrical injuries. When working with electrical equipment, several safety measures should be followed to minimize the risk of electrical shock, arc flash, and other hazards. Firstly, always de-energize equipment before working on it. This means turning off the power at the source and verifying that the equipment is no longer energized using a voltage tester. Lockout-tagout procedures should be implemented to prevent accidental re-energization of the equipment while work is in progress. Secondly, use appropriate personal protective equipment, including rubber gloves, safety glasses, and insulated tools. The type of personal protective equipment required will depend on the specific task being performed and the voltage levels involved. Thirdly, maintain a safe working distance from exposed energized parts. The safe working distance, also known as the approach distance, is the minimum distance that a worker must maintain from exposed energized parts to avoid the risk of electrical shock or arc flash. The approach distance varies depending on the voltage level of the equipment. Fourthly, be aware of the potential for arc flash. Arc flash is a dangerous electrical explosion that can occur when a short circuit or other fault occurs in electrical equipment. Arc flash can cause severe burns, blindness, and even death. Wear appropriate arc-rated clothing and personal protective equipment when working on or near energized electrical equipment. Fifthly, never work alone on energized electrical equipment. Always have another qualified person present to provide assistance in case of an emergency. Sixthly, regularly inspect electrical equipment for any signs of damage or wear. Damaged equipment should be repaired or replaced immediately. Seventhly, follow all applicable electrical safety codes and standards. These codes and standards provide detailed requirements for the safe installation, operation, and maintenance of electrical equipment. Eighthly, if you are not qualified to work on electrical equipment, do not attempt to do so. Call a qualified electrician to perform the work. Ninthly, be aware of the presence of underground utilities before digging. Contact the local utility company to locate any underground utilities in the area before starting any digging work. Tenthly, never use water to extinguish an electrical fire. Water is a conductor of electricity and can create a shock hazard. Use a fire extinguisher that is specifically designed for electrical fires. By following these safety measures, you can significantly reduce the risk of electrical injuries and fatalities in the workplace. Remember that electricity is a powerful force, and it must be treated with respect. Always follow all safety procedures and use appropriate safety equipment to protect yourself from electrical hazards. In summary, always prioritize safety when working with or around electrical equipment. Ensure you are adequately trained, equipped, and knowledgeable about the potential hazards and safety procedures to minimize the risk of accidents and injuries. Stay informed about the latest safety standards and regulations to maintain a safe working environment for yourself and your colleagues. Always remember that prevention is key when it comes to electrical safety. By taking the necessary precautions and following established safety procedures, you can significantly reduce the risk of electrical accidents and create a safer working environment for everyone.